This is problem of the day, and definitely I should tell you that every single day we solve problems in terms of physics, maths, and then commerce, English, then also the other subjects. And in a way or two, every student will benefit from this particular channel. And if you follow us for a very long time, you would get enough benefit. We believe that we come up with the best solutions in terms of solving Wassce problems, and we explain them in a way that you get the concept, so that when it's time for your Wassce, you wouldn't struggle as others do. And due to that, let's look at this question. There is a problem in physics, and the question says a car has a coefficient of friction between the ground and its tire of 0.85. What is the mass of the car if it takes a force of 9,620 newtons to make it slide along the ground? So for those of you who don't do physics, in a way or two, you can keep on watching this video, but it is specifically for the physics students. And for everyone who is in Form 1, Form 2, Form 3 should be able to solve this problem, because it is a Form 1 first term topic problem, and it's a problem under forces. And if you've learned forces, big ups, follow along as we do it. And if you've not learned forces, no big deal. This example, I will explain it in a way that you get the concept very well. First of all, let me explain it in tree. The question says car B, and then car no coefficient of friction as 0.85. And by the way, only coefficient of friction, don't worry, you'll be explaining. The question says I am finding mass of the car because what my force, and a force now the mine is 9,620 newtons. And I'll say the force that has been given right now, in other words, force now body was is here, and only force now a baby pushy car no to slide along the ground. Because a slide along the ground, it means a carnage now. Until upper force ipia, and I say the car can so I can't bet me idea. I shall say a movie. In other words, force now was the engine no I apply to car no for the car to move. And as you want the nipa bi na ekopia car na and one day nipa na also wonya ansa na opia car no. They say be a car is one the nipa 10 ekoja so mumpia. That's all energy no, and I say sorry, force no. I mean this time you are considering force and not energy. Into force no, so force no less than, and as any nipa 10 no, so force no and drew 9,600 newton na car ni move. That means the nipa base at 20 normal force ni be drew 9,620 and when the bema car na move. So the force given here is the force that can start motion in the car, or is a force that will cause the car to start moving. So there's a story about the car. And definitely we all know that formulas are giving acceleration, blah blah blah. But this time, one might those kind of stuff, or they are buying a form of story. And this is also story in Asia that will give you the permission to solve the problem. So I raised some explaining for you to get it clearly. And first of all, entry BB in terms of coefficient of friction. First of all, my memory of black screen. So let's consider something like a bus on a table. So this is my bus on a table, okay? And I say any object on a plane. We all know say for every object, it has weight. That is the reason why I use a BB mode. Until this object is having weight, which is a weight, is actually applying downwards. Until weight is affected by your mass and then the acceleration due to gravity. Okay, until adimu drone, a mass na the crano and then acceleration due to gravity. Okay, until for this particular adena at that table no so no weight no I apply to the table. The weight no once force no one say it's applying the weight, which is a force, to the table. And a per Newton's third law no say for every force there is an equal and opposing what force. And a motion third law no say for every action there is and a motion. And a Newton's third law say for every action there is an equal and opposite reaction. Inti okasa or patches a force na apply on the table, which is the weight That table na say that table apply the same force to box That force near friend reaction. So that force is facing upwards reaction. Inti motion now inti Newton law no cannot say times our box where weight which is natural. I mean the mass times the acceleration due to gravity I apply on the table Jamazenka ukuna okra boss na nasa una oswa boss na utibe because the weight of the boss apply wuti so. Jamaze this time table ni wuti. Inti boss na isi wuti so weight na apply is the weight of the boss. Utinos apply the same force emma box Inti na sa utina sia chabo na otoya In fact, I want to say, you are applying your weight on the chair, and a chair no amount the same weight now applying back to you. So weight in a friend reaction. This time, not table no so chana sa akunya no so cha ones now to your ya. In fact, una oti akunya no so nya akunya net also but to your ya because akunya no amount the same weight now the man. That is called reaction. And friction is such that it depends on this reaction. The reason why it depends on reaction is force now air coming back to the object, see a movie object in this direction now. Okay, force it's also moving in this direction. We all know that friction opposes the motion. Someone said this is the original force, capital F, causing the object to move in this direction. Into friction is making sure that Emma didn't this direction, but rather stopping it from going into this direction. Into friction is working in this direction, and the friction is now reaction also. At the end of drone about friction, I am more. Is it I say assassin roughness no? Ebema friction I am more, and as I didn't move draw I am more. It is say your land we na rough say ya. Na say ode bibi to say na ade no emunye to gidi ya. Ansa ne bedru hanum say no. Na bi akake to abi. Say the am say we ayekese emu du pa. Ansa ne be roll ya kwa hanum say no. Na fe the force na affecting the baby because this time no reaction is in action. And friction depends on action. It's mathematically in electronics say friction, which is a force, it depends on reaction. Okay, friction is a reaction. So into this time now, friction is a reaction. Also, no, we solve this in such a way that you are making a formula. Most of the times, most of the times, you changes are dependent here. Near an equal sign. This time, you're equal to the constant. This time, your friend in mu. The mu r. This is not w, it's mu, okay? The mu r, the friction way is equal to mu r. So mu no, and your friend coefficient of friction, okay? I feel what's the story in Asia. The same mu no your friend coefficient of friction. So back to the question. The back question or the is a coefficient of friction, okay? And I say 0.85. This time, in a way, so drive an electric car for where 2 months are kind ties never say because coefficient of friction does more often than a coefficient of friction. Back to my black screen, it lies from 1 to 0. It has a free 0 and drew 1. This time it is 0.85, almost 0.9, almost 1. And in this case, it's too high. Ties never saying them. You see that say assassin is too rough to make the car ties comfortable. And I say car no mood and a ties getting a ties no more handy can the pressure be receive ties and I'm a ties no like tiny bread. Okay, so in this case, can't be saying them because coefficient of friction so a purchase a friction power air apply on the car no is too high for the car to last long. Okay, back to the question. I say we are supposed to find the mass if a force of 9,620 newtons is to make the car slide along the ground. So this time now, we'll make a keyword go and say and slide along the ground and the patches and not carnage now. Okay, definitely force are ebema car no I shall say moving on the mind as I explained earlier. So now with these things given, how are we going to find the mass? So first of all, let's give out our preambles, and as our staff know, we were giving them the mu to be 0.85. Notice that it has no unit, and the reason why it has no unit is because we all know that friction is equal to mu r, where our friction, when we make mu the subject, or when we divide both sides by r, we are going to get r. This time mu will be the subject. In this case, mu is equal to friction all over reaction, where the friction, the SI unit is in newtons, and then reaction, the SI unit is in newtons. So this will cancel that. That means the coefficient of friction is going to have no unit. So we're giving the coefficient of friction to be 0.85, and it says what is the mass. So let's m be our mass. In this case, we don't know. So I will still say M. And then we were given the starting force, the force that will start the motion. In this case, Maminka said a capital F. That was 9,620 newtons, right? So in this case, no, in this case, no, my number, so we are supposed to find the mass. So how are you going to find the mass? Let me draw a diagram for you so that the diagram will be explaining. This particular thing, instead of any specific formula, it has we derive the formula from the story, okay, near the high work, sometimes physics said thing. So you learn the formula and then it's in your head, but story in one here, you will not even know that is the formula you're supposed to use. In the car, no, and there's a force that is moving the car. So in this case, the force that will cause the car to move in this direction is 9,620 newtons. Notice the friction is actually between the ground and then the tire. So that friction is in this direction. I mean, that's a small f. And I'm saying that friction is opposing the car. No? It is also facing the opposite direction, right? It's a car be moving there. It is carrying some. And before a car be moving, no, it is actually static. We all know that for every force, it is actually giving us mass times acceleration. Notice that car the acceleration is equal to 0. The car movie, but the force we never make an movie. Yeah, apply no more than this force and never make any acceleration. So still acceleration is equal to 0. And so we should note that the way ever mass formula more. Let me say this is my big F. My friction is my small f. Okay, so you calculate that. Okay, so in this case, my MA is what you're supposed to find. The formula is a capital F, which is this one, or which is the force causing the car to start moving, is minus the friction, because the friction is opposing it. That will cause this car to still be standing there, because more than that, some acceleration. Notice that you apply force now, it will cause the car to have some ability to move. More than the force, never can move, because if force when you overcome car in this case, the mass of the car, which is the effective force, should in case the car move, the effective force of the car, the car boa force na ekrano and you calculate. That will be the mass of the car times acceleration of the car, speed in our car. I mean, that speed increases with respect to time. Okay, so in this case, our main force is this, which is 9,620 Newton minus our frictional force. Notice that our frictional force was given as mu r. We all know that r is the same as weight. That means weight is the same as mg. That means mu mg, right? Because we know that r is the same as weight and weight is the same as mg. That means mu mg. Okay, then afterwards, that mu mg is equal to the mass times acceleration. This time, can a move and the acceleration is equal to 0. So in this case, 9,620 Newton minus mu mg is equal to 0. Me make you about say 9,620 Newton is equal to mu mg. Notice mu in the bottom is positive. And then now we can insert in our values. So notice 9,620 is equal to the mu of 0.85. And then the m, we don't know, the g is 10. So 9,620 is equal to 8.5 m. And then we can divide both sides by 8.5, and that will give us 1131.765 kg is equal to the mass. So this time our mass is equal to 1131.765. I've run it to 3 decimal places. The mass now can is the mass. So 1131.765 kg is the mass. In other words, this time, cars that weight 1131 might be around these mini cars, Toyota, and then these racist cars, once those cars, the money do. Okay, at the end, and then the numbers 3,000 kg, 4,000 kg. You can start thinking of these heavy cars, okay? So in this case, the car is not small. And also, those cars now sometimes are more tight internal coefficient of friction also. And this is the problem of the day. Thank you very much. I hope you understood this physics. So indeed, the question said, and finally, the mass, it gave us coefficient of friction, and then it gave us the starting force. Actually, this is something that when you understand the story critically, so if you know a formula, that's fine, but it doesn't mean that you should throw your formula away and then try to understand the question. And I know that during that time, physics will be simple for you. So that's the very video. I really appreciate your time